Hey everybody, this is Mr. Beckstrom, and today we're going to go over section 3.7, the chain rule. The chain rule is probably going to be used more than any other rule that we have, except maybe the power rule. So it's very important to understand the chain rule, and it's also really important to do a bunch of examples because we're going to see the chain rule in a few different forms. Sometimes we're going to see it using the power. Sometimes we're going to see it with E. Sometimes we're going to see it with trig functions. Sometimes we're going to see it with logarithms. So there's quite a few different, completely different situations and examples that we're going to see. And I want to make sure that we at least go over a few representative examples, make sure we understand. But basically what it's saying is that if we have a composition function, or composite function, excuse me. That's where one function is nested inside another function. Then we can apply the chain rule. And I almost always use the definition 2 here, where the derivative of a function inside a function is going to be the derivative of the inside function times the derivative of the outside function. And you might say, well, what the heck does that mean? Well, in this case, more than probably any others that I can think of, it's really important to take a look at some examples. So let's go ahead and jump into it, and then we'll talk about it a little bit more as we kind of look at those examples. All right, so this first one here, y is equal to the sine raised to the fifth of x, is a perfect example of when we use the chain rule. The first thing I want to do is I want to rewrite this a little bit so it looks kind of like the theorem 3.14, the chain rule for powers. But remember, putting the 5 here for a trig function is the same thing as putting the trig function with the 5 completely on the outside. So this is really equivalent to sine of x raised to the 5th power. So these two things are the same thing. They just write the 5 here. It's really just a shorthand version specifically made for trig functions that really doesn't work for a lot of other functions that we look at. But if you look at it like this, then we can kind of look at it like this right here. So for finding the derivative of this function, we have a g of x here, and then we have a p there. So really what they're doing is, and you can go straight through this, but I'm going to kind of explain to you how I understand it, and then if you want to look at some examples in the book and see which one makes better sense or which one you like more, go ahead. But I look at this thing inside here as like a u, right? So if you just look at whatever's the inside function, the inner function, look at that as some variable. Doesn't matter what variable you pick. Then what we're doing is we're really doing the derivative of the u times the derivative of kind of like a u to the 5th here. So the inside function times the derivative of the outside function. So in this case, y prime, or the derivative, the inside function here, sine x, the derivative of sine x is cosine x. So you're just going to write the derivative of the inside function. That is this part right here, the g prime of x. And then we're going to write the times the derivative of the outside function. So now this is where you treat this like u here, u to the 5th, and you're just going to use the power rule. So that's times 5. You keep the same inside here, sine, and then you reduce the exponent by 1, and I'll go ahead and put it back in there like this. And then if you just want to pull the coefficient out front, you can do that. So you're going to get 5 cosine x sine to the 4th x. And that's the whole thing. So you just take the derivative of the inside function times the derivative of the outside function. And we have to remember, whenever we take the derivative of the outside function, you're going to keep the inside just like it is. All right, so let's take a look at another example here. All right, so here we have e to the 4x squared plus 1. So we can look at the 4x squared plus 1 as our inside function, and then e to the u is our outside function, e to basically this thing. So when we do the derivative, it's going to be y prime is going to be the derivative of the inside function. So we're going to use the power rule in the inside function. So bring the 2 out front, multiply it by the 4, we'll just get 8x, and then times the derivative of the inside function. Remember, the derivative of e to something is just the same thing, e to that something. So it's just going to be e to that same thing there, 4x squared plus 1. That's pretty much it. So nice and easy. So derivative of the inside function, derivative of the outside function. All right, let's take a look at another example. All right, so we have y is equal to tangent of e to the x. So go ahead, pause the video, see how far you can get, and then we will do this one together. All right, so we can write this basically as, oh, I keep moving the screen around here, as, get this right, tangent to the u, right, where u is equal to e to the x, right? So in order to find the derivative here, we're going to do the tangent of the inside function. So, excuse me, the derivative of the inside function. So y prime is going to be equal to the derivative of u, which is just the derivative of e to the x, is just e to the x. And then the derivative of tangent of u is just tangent u secant u. I'm actually thinking of the derivative of secant of u. The derivative of tangent u is secant squared of u. So this is going to be times secant squared of whatever this u is, and that's e to the x. So we're going to have e to the x times the secant squared of e to the x. And that's it pretty much for that one. There's not really much else we can do with that one. So let's take a look at a harder example. Let's see where we actually have chain rules nested inside chain rules. All right, so now we have y is equal to the 4th root of 2x over 4x minus 3. So this is a little bit harder here. So go ahead and see if you can solve this one, and then come back for the solution. Okay. So here, when we try to write it as a composite function of one function nested inside another function, the first thing I can do is change this this 4th root to exponent, where it's just this function here raised to the 1/4. So this is really equal to, and this is just a little bit more for aesthetics. Whenever I'm doing derivatives, I always convert all of my radicals into the exponent form. So that's equal to that. So now we have this as the inside function, right? To the outside function would be u to the 1/4. So it's the derivative of the inside times the derivative of the outside. Let's go ahead and do the derivative of the outside first here, because that's going to be the easy one. So the derivative of the outside, just using the power rule there, with, right, 1/4. Keep the same inside here, 2x over 4x minus 3, and then this is raised to the negative 3/4 power, 3/4 power, because we subtract 1. But we also have to do it times the derivative of the inside. And the derivative of the inside is going to be a little bit trickier. So if I was writing this down, I might just leave the derivative notation if I don't quite know it yet. So I'll say times the derivative with respect to x of the inside here. So we can do that, and that's fine when it's not an easy thing to figure out. Now I can kind of go off to the side and figure out what the derivative of this function here is. And I'm going to use the quotient rule. So the derivative of this here would be the bottom. So 4x minus 3 times the derivative of the top, which is just 2, minus the top, which is 2x, times the derivative of the bottom, which is just going to be 4. All over the bottom squared. So all over 4x minus 3 squared. And this is just the quotient rule for finding the derivative there. So cleaning this up a little bit, I'm going to get 8x minus 6 minus 8x. All right, the 8x will cancel out, so I'll just have a negative 6 on the top, and on the bottom, I'm just going to leave that as 4x minus 3 quantity squared. So now it's just really a matter of replacing this whole thing here with this here, and then simplifying. So this is going to be equal to 1/4, and this is times 2x over 4x minus 3 raised to the negative 3/4 power times negative 6 all over, this should be a times, not a minus, all over 4x minus 3 quantity squared. All right, so let's see what we can do here. Really, we want to bring this down to the bottom because, well, actually what we can do, so we can do a little bit of algebra here, and a little bit tricky, but the first thing I'm going to do is let's pull that 6 out front here. So that's going to be a negative 6 over 4, which is negative 3 over 2. And then what I'm going to do is I'm going to write each of these separately to the negative 3/4 power. So this is times, this is going to be 2x to the negative 3/4 power. And on the bottom, we're going to have 4x minus 3 raised to the negative 3/4 power, and this is going to be times, and then we already pulled the negative 6 out of there, so this is just going to be 1 over 4x minus 3 squared. All right, now that we have the same base here, we can just add the exponents up, and since this is a negative exponent on the top, I'm going to bring it down to the bottom, and we're going to do a little bit more work here. So this is going to be equal to negative 3 over 2 times, so we'll just have a 1 on top here. We're going to bring that down to the bottom, and I'm going to apply those separately. So I'm going to have 2 to the positive 3/4 power times x to the positive 3/4 power, and then we're going to have combine these two. Negative 3/4 plus 2 is 5/4. So this is times 4x minus 3 raised to the 5 over 4 power here. That's all on the bottom. And really the last thing, if you want to match the book's answer here, is we'll have a negative, we'll have the 3 on top. The 2 times the 2 to the 3/4, you just add the two bases. So you just add 1 plus 3/4, which is 7/4. So on the bottom, you're going to have 2 to the 7/4 power times x to the 3/4 power times 4x minus 3 raised to the 5 over 4 power. So don't forget the negative out there. And this one is done. Now, if you're doing this on a test and you get to this step here, I'll probably go ahead and give you full credit for getting to this step right here. This is just kind of getting rid of your negative exponents, combining things that you can, and doing all that good stuff. All right, let's take a look at one last example. All right, here we have y equals 2 to the ex plus 3 to the e to the negative x all over 3. So what I want you to do is go ahead and pause the video, try this out, see how far you can get, and then we will go through the solution. All right, so this looks like a prime candidate for the quotient rule here, but I'm going to show you a little bit of trick, or a little trick here. And now this is what I do. You don't have to do it, but I find that if I can break this into separate fractions pretty easily, like I have one term here on the bottom, often that'll make my job a lot easier. And in this case it will, because the quotient rule is, let's face it, mathematically it's kind of yucky, right? So I'm going to rewrite this here to y is equal to, and this is going to be 2/3 e to the x plus 3 over 3 cancels out, so you'll just have e to the negative x here. Now we can just use that good old sum rule, break those up, and these look like pretty easy derivatives here. So let's do this. So y prime, we're going to take the derivative of this to the first. Remember, if you have a constant multiple, you can just ignore it and put it in at the end. So the derivative of e to the x is just e to the x, and then we just put that 2/3 back in. So it's going to be 2/3 e to the x. Now we're going to use the chain rule for this one. So it's going to be the derivative of the outside. So the derivative of e to the negative x is just e to the negative x times the derivative of the inside, which is the negative x here. And the derivative of negative x is -1. So we're just going to get -1 times e to the negative x, or minus e to the negative x. And that's it. That's it. A lot easier than it looked. And really, it's I think a lot easier than trying to use the quotient rule there. All right, guys. I hope this helped. Please try some of these examples here. See how you do. And let me know if you have any questions. Have a great rest of your week. Thanks.